Alright folks, gather round because we've got some exciting news to share. There's a new AI in town. And let us tell you, it's giving DeepMind's AlphaGo a run for its money. This AI is so impressive that it can defeat AlphaGo in mere seconds. Can you believe it? Now, you might be wondering how this is even possible. In simple words, it's an adversarial attack. Well, let me break it down for you. This new AI has been trained using some seriously advanced algorithms, and it has been fed an immense amount of data and has been taught every trick in the book when it comes to playing. Look at this. So you know these sneaky little tricks people play on AI models. Well, they're called adversarial attacks. Basically, these attacks mess with the data that AI models have learned from and make them come up with all kinds of wrong answers. Still scratching your head at what really this AlphaGo is? AlphaGo, the raddest computer program ever, totally crushed it when it came to playing Go. It beat all these top-notch human Go players and even snagged the title of the strongest Go player in history. Like, that's seriously impressive. Go is like super complex and has always been a tough game for AI to crack, but AlphaGo took on the challenge and totally nailed it. See, other AI programs could only play at an amateur level because they couldn't handle the insane number of moves in Go or figure out which board positions were strong. But not AlphaGo. This cool program used a mix of advanced search tree techniques and deep neural networks to dominate at Go like no other. It processed info about the game board through layers and layers of neuron-like connections in its networks. And get this, it learned from experience too. Through reinforcement learning, AlphaGo just kept getting better and stronger. It went on to whoop some serious butt against world champion Go players from all over the globe. We're telling you, AlphaGo became the greatest Go player ever known. That's absolutely mind-blowing. So, how does AlphaGo do its thing? Basically, it starts by checking out the board and trying to find some patterns. And then it uses these patterns to try and figure out the best move to make. Now, we gotta admit, the predictions aren't always spot on, but they're usually pretty darn good. Go is a super complicated game with a gazillion possible moves, so even the pros can only think about a tiny fraction of those moves. But AlphaGo? It's got some serious brain power. Now, picture yourself playing Scrabble, right? And then out of nowhere, somebody goes ahead and messes up all the tiles so that pineapple turns into apple pie. That's pretty much how an adversarial attack works. Back in the day, it wasn't a big deal if AI models gave some wrong outputs. But now, things have changed. People demand perfection from AI, and any mistakes are seen as major issues. These inaccuracies can be life-threatening when AI models are applied to real-world situations, making adversarial attacks extremely dangerous. For example, putting stickers on traffic signs can confuse a self-driving car and make it veer into traffic or crash into an obstacle. There are a bunch of cool techniques you can use to generate adversarial attacks. One common approach is gradient-based attacks, where you basically take advantage of the model's loss function gradient to create those sneaky adversarial examples. On the other hand, decision-based attacks play with the model's decision boundary to come up with their own set of adversarial examples. And hey, physical adversarial attacks are another way to mess with models, by actually tweaking pixels in an image or playing around with sound waves. In this super interesting case mentioned in another research paper, there was this neural network that correctly identified an image as a horse. But get this, by changing just one pixel in the same image, all of a sudden the neural network saw it as a frog. Crazy stuff, right? Now, don't go thinking any old random pixel change will do the trick. This fancy attack knows exactly what it's doing and carefully tweaks that one pixel to completely mess with how the network interprets things. There are also similar attacks out there with their own little twists and turns that achieve similar results but with slight differences in how they go about it. Pretty wild stuff, huh? There are two main categories of attacks that can be used to analyze and test the vulnerabilities of an AI system: black box attacks and white box attacks. Black box attacks are more general in nature, where the attacker is simply trying to determine if the corruption of data is affecting the model. On the other hand, white box attacks are more targeted and assume that the adversary has access to the model's parameters and can obtain labels for the provided inputs. One of the methods used in white box attacks is called fast gradient sign method. This technique was developed by Google researchers Ian J. Goodfellow, Jonathan Schlenz, and Christian Szegedy as one of the first attacks for generating adversarial examples. It involves adding imperceptible noise to an image in order to trick a model into misidentifying it. The amount of noise added is calculated by multiplying a small constant epsilon with the sign of the gradient with respect to the desired image. These different attack methods can provide valuable insights for initial problem analysis and greatly assist engineering teams in improving system security. So basically, with black box attacks, the bad guys can only get outputs for certain inputs, and they don't know anything about the model itself. They can create an adversarial example using either a completely new model or no model at all. This attack is considered efficient because it only needs access to the regular output class for any given input. Unlike the square attack, the hop-skip-jump attack doesn't require gradients or score values. In the world of deep learning AI, there's this game called AlphaGo that's been a big deal. Humans used to be able to beat even the best AI players in Go up until 2016. On a related note, have you heard about DeepMind's AlphaGo? It's an AI that revolutionized the game of Go by using deep learning neural networks to teach itself how to play. Before AlphaGo came along in 2016, humans were still able to beat other Go-playing AIs. But not anymore. AlphaGo showed us what deep learning can really do. Now there's AlphaGo, another open-source AI for Go, that's beating top-ranked human players left and right. It's pretty impressive. AlphaGo's AI is seriously impressive. It learned the game of Go by playing millions of games against itself, which makes it one of the best out there. However, even with all that experience, there are still some vulnerabilities from unexpected behavior. It's fascinating to see how it compared to other legendary systems like AlphaZero and AlphaGo Zero, which have beaten some of the top human players. What's even more amazing is that AlphaGo was trained from scratch and didn't rely on any human knowledge. It discovered all of its abilities on its own, and now it's even taking on competent image recognition AIs. This amazing painting by Van Gogh, called The Starry Night, is recognized by the red frame around it. But here's where things get interesting. When we add carefully crafted noise to the painting, nothing happens at first, but if we wait a little longer and continue the process, you'll see that the noise ends up looking completely different from Starry Night. Now, let me introduce you to AlphaGo. It's a system that makes several small changes to improve efficiency and usability for the Go community. Just like AlphaGo, AlphaGo is trained from scratch using self-play reinforcement learning, and it has 4 major improvements that make learning much more efficient: playout cap randomization, forced playouts, and policy target pruning, and global pooling. One of the simpler improvements in AlphaGo is the introduction of occasional global pooling layers. This allows the network to take into account board areas that may be outside the reach of the conventional layer's perception radius. It's a great addition that enhances the overall performance of AlphaGo. So, in a recent interview with David Silver, the lead researcher of AlphaGo, he mentioned that he expects AlphaZero-style bots to keep getting better for the next 100 years. According to him, the skill ceiling of Go is still nowhere in sight. AlphaGo offers a glimpse into how further improvements can be made, and how it can benefit human players along the way. For AlphaGo, it's not just about improving playing strength. It's also fascinating to see how AlphaGo has enhanced its usefulness as an analysis tool. Through score estimation and territory ownership prediction, will the future focus more on adding layers of interpretability and analysis utility for players? Or is strengthening and improving training efficiency still the main priority? We'll have to wait and see what unfolds, but until then, make sure to subscribe to our channel.